release process. So as we know that cultivar or variety is originated from two words, cultivated variety. It is part of cultivated and part of variety. So it is cultivar. So cultivar means intentionally bred using cultivation methods by plant breeders. So the genotype which commences is known as cultivar. A plant variety is a legal term for the cultivar as per the UPO guidelines. And this practice is commonly referred to as plant breeders' right in development of variety. The term plant variety describes a legally protected cultivar. So variety and cultivar both are same thing. So as we know that in crops, there are three types of crops: self-pollinated crops and cross-pollinated crops and vegetatively propagated crops. In any of the varietal development program, these are the 4 steps: breeding a new variety using different breeding methodology, varietal evaluation under a CRIP system, release process, and seed production. So for any of the cultivar development, basic requirement is well-defined target-oriented objectives. These may be yield enhancement, disease resistance, quality improvement, or climate resilience and abiotic stresses tolerance, or sometimes it is product specific for different quality parameters. Among vegetables, there may be different objectives like maturity, growth, wider adaptability, protein sensitivity, growth habits, fruit shape, size, like that. So these are the basic requirements for initiation of any of the breeding program. So as deal with the methods of breeding, there are 3 different types of crops. So one is autogamous or self-pollinated crops. In this, these are the basic methods which we commonly use: introduction, pure line selection, hybridization followed by selection. Among these different manipulations are there: pedigree method, bulk method, backcross method, single seed descent, modified bulk, mass pedigree method. These are different methodology with slight modifications with each other. Interspecific hybridization of using 2 different species, multi-line cultivars, hybrids, mutation breeding, polyploidy, and some of the innovative and molecular techniques for development of varieties. These are the list for different methodologies in self-pollinated crops. And in this, pedigree method is also known as combination breeding, when better traits from 2 different sources need to be combined in one genotype. So we use pedigree method. Bulk method is mostly used for abiotic stress tolerance breeding, when we wait for suitable target environment to commence and expose the crop to breeding material to that targeted environment. Another is backcross method, which is mostly used for biotic stress systems breeding. In this, gene transfer from a donor parent to agronomically superior cultivar is being done. So these are the very commonly used methodologies in autogamous plants. In cross-pollinated crops, there are methods of introduction, mass selection, different selections schemes, hybridization. In this, single cross hybrid, double cross hybrids, top cross, and composites and synthetics are there. Interspecific hybridization, mutation breeding, polyploidy, and molecular tools. These are the listing for cross-pollinated crops. Among these, there is one term is coming: multi-line varieties, mostly in self-pollinated crops. So it is the mixing of number of isogenic lines. Isogenic lines means the lines which are differing at one locus only. Almost all the traits are similar, but differing for one traits. So in wheat, first time the multi-line varieties were developed, MLKS 10, 11, and B2. So in this, they are resistant for different rust pathotypes, and other traits remain same. So mixing of that different isogenic lines made multi-line varieties. Composites and synthetic cultivars are commonly used in cross-pollinated crops. A composite variety is produced by mixing the seeds of several phenotypically outstanding lines. And in this, open pollination is being done among themselves, and process the seed has been harvested from the cross material, and these are mixed. So it is composite variety. For synthetic varieties, it is also developed in cross-pollinated crops like palm millet, cauliflower, onion, carrot, and other crops. In this, the combining ability is being tested. In composite, there is not much required. That's why it is only difference. Just a minute. Another is the excessively propagated crops. In this, four major methodologies are introduction, clonal selection, mutation breeding, and polyploidy breeding. In this, clone is very popular term, and the clone is all the individuals belonging to a single clone are identical in genotype. It is the foremost condition. Any of the phenotypic variation within a clone occurs due to environment only, and they are theoretically immortal, highly heterozygous, and stable, and can be propagated generation after generation without any change in the phenotype. So these are known as clones. So mostly these are used in asexually propagated crops. Supportive role, there are oxygen nursery facility which supports the breeding methodology, integration of molecular approaches like marker-assisted selection and marker-assisted backcross breeding. These are different molecular tools for integration in the breeding methodology, and physiological parameters for faster screening of the genotypes against climate resilience or abiotic stresses, or CTD, canopy temperature difference, NDVI, and other root traits like that. So these are the supportive role to the normal conventional breeding programs. Among these, there are some new initiatives have been developed, and these are the new terminology which most of the student and the young men should know. The shuttle breeding, speed breeding, and participatory approaches for plant breeding, varietal selection, and seed production. So shuttle breeding is the shuttling of the breeding material among the two locations. One is the main center, and the another is the specific targeted environment of abiotic stress. Mostly it is used in abiotic stress conditions for screening the material, and it also reduces the breeding cycle just half. So in case of wheat, we use normally Dalang Maidan and Wellington stations for shuttle breeding of the material. Speed breeding is another terminology in which the light spectrum is being manipulated under controlled conditions, and in this the breeders are able to take 5 to 6 generations within a year. So it is very fastening methodology for speeding up the breeding method. Participatory approaches are in align with the farmers. Some of the progressive farmers are taken in team, and the plant breeding activities or varietal selection or seed production is being taken at their field. So it is participatory plant breeding. So for foremost inputs is the selection of parents. The parents may be germplasm lines, suitable agronomic base. There should be a suitable donor parent as a parent. So cultivars may be pure line, hybrids, composites, and synthetics. In pure line variety, it is the result of cross between two or more different varieties and subsequent selection cycles through several cycles, which we call F1, F2, F3, F4, F5 filial generations. And in the last, we make station trial, PYT, and multi-location trials, and then go for coordinated system of evaluation and release of the varieties. Another is hybrid, which is the first generation of a spring of a cross between two genetically diverse parents. In this, hybrids are the heterozygous in nature, uniform by phenotype, and they will not be bred true if sown again because of inbreeding depression. We normally prefer hybrids due to 15 to 20% of yield advantage, which what we call as heterosis, giving higher economic return. And hybrids are present in all biological systems and have been exploited commercially in many agricultural crops, specifically in cross-pollinated crops. So this is the heterosis. There are 3 different types of heterosis: mid-parent heterosis, high parent or better parent heterosis, and commercial or standard heterosis. These are the formulas to calculate the heterosis over the mid-parent or better parent or commercial check. In self-pollinated crops, for development of hybrids, there is 2 steps: parental line development. It may be due to by hand emasculation or using male sterility or self-incompatibility system, and then hybridization of male and female parents and evolution of hybrids. So in male sterility systems, they may be either genetic or non-genetic. So cytoplasmic genetic male sterility is the genetic system, and environmental sensitive genetic male sterility system is also affected. There are some conditions where male sterility is occurring due to difference in temperature regimes or photoperiod, or both photoperiod and temperature. And another is chemically induced male sterility, in which gametocytes are used for creating male sterility in female parents. So for development of hybrid cultivars, there are 2 terminologies of 3-line system and 2-line breeding system. In 3-line breeding system, there are 3 parental lines, A, B, and R line. A is male sterile line, B is maternal line, and R is the male parent. In 2-line system, there are 2 parents only, male and female, and it uses chemical method or environmental PGMS or PGMS system. So identification of best combiners is based on general and specific combining ability, and the produce of experimental seed of best specific combination, that is hybrid, is used for evolution. So in 2-line system, you can see in the figure that there are maintenance of S line, female line, and then it is crossed with male parent, and the F1 is obtained as hybrid. In 3-line system, we have to maintain CMS line, male sterile, using maintainer line. Maintainer line is isogenic line to A line, differing at sterility locus only. And then A into R line is crossed for getting hybrid seeds. So this is the 3-line system. For production of an F1 hybrid variety, hybrid cultivar using CMS system, there are three lines. A line is being crossed with B line for maintenance purpose, and then A line is crossed with R line to get a hybrid. It is pictorial representation. So I have worked mostly on wheat, so most of the examples will be from wheats only. So you can see the male style florets and fertile florets, and these cross you can get the hybrids with allele cytoplasm. In field, it looks like this one. In below, you can see the male style pollens, which are transparent one. And if it is male fertile, it will be dark stain color. So this is the breeding methodology in field, where in sites there are 2 maintainer lines, and in between there are 4 male style lines. So the seed harvested from the A line is being used as a female parent. This is the system for development of experimental hybrids. In this, you can see the borders, light green borders of oat as a separator. And in between, there are 2 rows on the side are the restorer lines, and 1 row in between. And the in between three lines are the different male sterile lines. So the seed harvested at these male sterile lines will be hybrid. So we can put number of CMS lines with one of the restorer because there is no pollens inside. So this is the methodology to develop experimental hybrids. Another is CHS systems, which is chemical hybridizing agents or chemical system. These are also known as gametocytes. So these are the advantages that fast and relatively easy to implement, and there can be many and virtually any combination can be explored at a time, and it doesn't require any of the pre-breeding activities for making better parents. But there are some disadvantages also. Very expensive to develop, industrial, highly stress dependent and weather dependent, and often non-complete sterility occurs, and phytotoxicity is another issue for concern. So it is not much used in Indian conditions. In environmental male sterility, there is PCMS, PGMS, TGMS, PTGMS, and MDMS, which can be, you must have read somewhere in the books. Some extra requirements are there for more pollination when we use the hybrid development technique. In this, there may be isolation or rope filling and supplemental pollination is there for increasing the pollination in female parent. And gibberellic acid application is also used for more pollination. Isolation is one of the system to maintain purity, and for that there can be three ways: either distance or flowering time or some barriers in between. There may be different types of pollination control system of unwanted parents. In cross-pollinated crops, it is the main example: pollen from male parent to female parent counts and hybrid occurs. So in this inbred line development methods are there. Different methods are there for inbred line development, which are being used as a female parent then. And in this, male rows are planted, and in between the female rows are planted. These are being detangled, and the harvested produce from the female rows are hybrids. So these are some of the characteristics of different types of single cross, three-way cross, double cross hybrid, or varietal cross hybrid. This I request the organizers to share with you so that you can better understand that what are different characteristic features in this different types of hybrids. For testing of genetic purity, there is grow-out test under field condition or in control condition, electrophoretic methods, and DNA fingerprinting is there. So finally, varietal development is hybridization, selection in segregating generations and advanced bulbs. Then comes preliminary yield trials, which we call PYTs, and station trials. Sometimes it is multi-locational. It is under different conditions. It may be under timely zone conditions or late zone conditions or rainfed or RI means restricted irrigation conditions. So this is the condition for wheat crop, and in other crops also there are different production conditions. And after this PYT and station trial, then cultivars enters to the coordinated trials. Coordinated trials being done by the national testing system in this All India Coordinated Research Project. It is different projects for different crops. It is crop specific. So the distinctive feature of working of the EQUIP is that scientists of all disciplines required for development of variety work together as a team in the planning and execution. So comes that what is coordinated trial? So there is set of genotypes, fixed designs, there is fixed replications, fixed plot size, same agronomic practices over the locations at different locations, and number of cooperators are there. So advantage that there is uniformity in recording of the data. Why it is tested in EQUIP? Because of stability in performance, responsiveness to different environments, collective testing, fixed sets, monitoring and evaluation is an integral part. It increases togetherness among the collaborative partners, and comparative performance of the varieties can be tested. So official testing program, there is 3 years of testing. In first year, initial varietal trial is there, and for 2 years, advanced varietal trials. Induction of test entries is based on station trial data and if superior to existing varieties. And all centers of breeding in ICR institutes or SAUs and private companies can enter their material for trials based on the specific quota allocated to them. In EQUIP trials, there may be different nomenclatures being used. IET, initial evaluation trial, uniform regional trial, initial varietal trial, national yield observation trial. But in wheat, we use national initial varietal trial and IVT and AVT, advanced varietal trial. And there may be some special trials for specific purposes. So this is the process for wheat testing program in coordinated system. The first year interzonal test is there. There are different trial series, and criteria for promotion is the yield potential, disease resistance, and quality traits. And after that, 2 years of advanced varietal trials are there, AVT1 and AVT2. In this, almost criteria same, but in the final year, there is addition of agronomical evaluations under different conditions to see the performance of the cultivar. So when coordinating system makes the trials, there are different steps: receipt of the seed, preparation of data booklets, coding of the entries, preparation of seed packets and dispatch, field layout and sowing, data recording, monitoring, and data reporting. These are different steps involved in the EQUIP system. So this is the layout In NIVT, you can see on the left-hand side that 2 replications in lattice design, and the AVTs are normally in replicated designs. All the ergonomic practices for trials is being supplied to cooperators to follow the uniform pattern for all the trials, which is example for some of the trials in AVT. Field design AVT is for 12 rows. In this randomized block design is used. Normally 4 replications are being put. In NIVT, we used to plant in 6 rows plot. In simple lattice design, it may be 5 into 5, 6 into 6, or 7 into 7. So it is advisable to plan the sowing well in advance to avoid different mistakes occurring. There may be different sowing methods by drill sowing, line sowing, or manual sowing for the equipped trials. So this is the example of labels, how we put labeling in the different entries. In this trial name is there, plot number is there, and entry code is there, so that the proper identification of the genotypes can be maintained. Then monitoring is there. So monitoring team constituted by involving breeders, pathologists, and agronomists of the centers, and one member is from equipped headquarters there. So monitoring team checks the sowing time and layout. What is the sowing time? What is the plant stand? Agronomic practices followed or not? Leveling, performance of testing, disease incidents, or physical damage to the crops due to sometimes rat or mealguy like that. So these are the different points which what monitoring team checks. In this, breeding trials are there, agronomical trials, pathological nurseries, physiological nurseries, and other nurseries are there which are being monitored by the team. So this is the condition. Some of the fields there are very less germination, and this in this well-managed trial is there. In this equipped system, there is no roving and no weeding is allowed to see the actual performance of the seed. So this is the monitoring. This is the data booklet. On above, there is data sheet for ancillary traits, and for down for ancillary sheet for yield traits, yield data, which is being filled and supplied to the operating center. Then comes to identification of variety. Identification of variety is being done by the Varietal Identification Committee, which is constituted, and this meeting is held during workshop. So in this proposal, including package of practices is submitted, and the committee sees the superiority, and there is condition that minimum 10 quintals of seed should be available in case of wheat. And likewise, in different crops, there are different seed requirement is fixed, so that we can put the varieties if released in the seed cell. So it is constituted by ICR. DDG Crop Science is the chairman of the varietal identification, and director of project coordinator is the member secretary, included as a director of research of that SAU, where workshop is being done. Agricultural Commissioner of Ministry of Agriculture or nominee, Director of Agriculture of the state or nominee, representatives of seed corporations, representatives of processing and marketing agency, and 2 eminent scientists are the member. They vote or decide whether it should be identified or not. And non-voting members are the head of the different disciplines involved in the testing system. So after one variety is identified by the VIC, then it put to CVRC, Central Variety Release Committee, for release and notification. It comes under Department of Agriculture, Cooperation and Farmers Welfare. The full form of CVRC is Central Subcommittee on Crop Standards, Notification and Release of Varieties for Agricultural Crops. In this, VIC proceedings are required with the proposal, and one seed submission certificate at NVPGR is required, which gives allocation of IC numbers. So that certificate is required. This CVRC committee comprises of DDG Crop Science as chairman. There is Joint Secretary Seeds, Ministry of Agriculture, Director of Agriculture of States, representatives of seed industry, and project director of different crops. And Deputy Commissioner Quality Control is member secretary of that. After release of the variety, it put to Gazette of India for notification. And after that, the seed variety can enter in the seed chain. So it is just for information that seed systems, there are two systems, informal system and formal system. Informal system is among the farmers, they may get in between the exchange or from market, but formal system involves the gene bank, breeding methodology, seed production, seed quality control, distribution to farmer. So it has a better quality system in formal systems. So seed production, when we do, it is nucleus seed. It is done by the concerned breeder. The breeder seed is by the breeder or the institute where the variety has been developed. Foundation or certified seed is being produced by the SFCI or NSC or seed companies under MOU or institutes, and seed growers and seed farmers can also produce the TL seeds. In hybrids, the parental lines are produced as breeder seed and hybrids are as foundation seed. So this is the generation system of seed multiplication: nucleus seed, NSS1 and NSS2, and then breeder seed, then foundation seed, then certified seed, and fully labeled seed. And these are monitored by the committee, seed certification agencies. Just a minute. And they issue different colors of tags for different seed categories, and from which you can identify that this is the seed of which has been certified by different agencies. So thank you very much for your